Hello. Today we are going to learn Taylor and Maclaurin series. Taylor and Maclaurin series are extensions of power series. In the last class we learned power series. Now it is easy to understand Taylor and Maclaurin series. Let's get the start. We know that sigma n goes from 1 to infinity, Cn times x minus a to the power n is a series where Cn's are constants. Alright, so this is actually called a power series. This is the format of a power series. Okay, let me add that word. This is a power series. Let me push this little bit that way. Okay, this is a power series. Alright, so that you learned in the previous section. Let's go forward. Taylor series is a power series where Cn's are approximated by using a function f of x, approximated by using a function f of x. Alright, the Taylor series is a power series. It's a special type of power series. Okay, in this special power series, the Cn's are approximated by that. Okay, approximated by this function. Now let's learn the definition of a Taylor series. Definition: sigma n goes from 0 to infinity, f to the power n of a divided by factorial n times x minus a to the power n is called a Taylor series Give me a second. Is called a Taylor series generated by the function f of x, all right, at x equals a. All right. So this is the definition of a Taylor series. Okay, the definition of a Taylor series. Taylor series is actually this representation of the power series, which is generated by f of x at x equals a. Okay, I will explain them later. Now I have to introduce you the Maclaurin series. Actually, Maclaurin series is a special case of Taylor series. All right. So you know Taylor series is a special case of power series. Maclaurin series is an special case of Taylor series. When a equals 0, that is sigma n goes from 0 to infinity, f of f to the power n of 0 divided by factorial n x minus 0 actually in this case. That means just x. Alright, so this is just x to the power n is called a Maclaurin series. I'm sorry, let me write it. Maclaurin Alright, let me write explicitly like f of x. Okay, this is how you define Maclaurin series. In the Maclaurin series, what you have is you have 0 for a. Okay, you have 0 for a. Now you see a here, a there, those values are zeros here. Alright, those values are zeros here. Now let's move to the first example so you can understand everything. Example number 1. Find the Taylor series at a equals 0 of the function f of x equals 1 over 1 minus x. Okay, now you have to compute the Taylor series of this function at a equals 0. Okay, this says Taylor series at a equals 0. That means Maclaurin series. Okay, Taylor series at a equals 0 means this equals Maclaurin series. Go to the definition. So this is the definition of Taylor series. All right. Here a does not equal to 0. This a does not equal to 0. When a equal to 0, it is Maclaurin series. Now come back to the example. Example number 1. It says find the Taylor series at x equals 0. In other words, here it is talking about the Maclaurin series. Okay, it is the Maclaurin series. But you could use any name you need. Either you could use Maclaurin series or you could say Taylor series at x a equals 0. All right, you could use any name you want. Let me take these extra lines out. Alright, now just work on this problem. Actually, Taylor series is written at a equals 0 is written like this. This is the given function f of x equals 1 over 1 minus x, which is given to you. Alright, which is given to you. And then you could write this as the Taylor series, that is this expansion. N goes from 0 to infinity, f n of a divided by factorial n x minus a to the power n. Here a equals 0. Since a equals 0, you have f of x equals 1 over 1 minus x equals sigma n goes from 0 to infinity f to the power n. Here a is 0 actually. 0 over factorial n x to the power n, because a is 0. Okay. Let me write, let me just modify this a little bit. Let me write with a equals 0. That's what this problem talks about. Alright. Now let me make a small note here. Actually, I would like to explain the meaning of this notation. Meaning of that notation. You might not have seen this. This notation refers to the nth derivative. Okay, nth derivative of f. This says the nth derivative of f. If it is the first derivative, you could say n equals 1. Okay, let me make a small extra note here. Alright, I'm going to put a small note here. F to the power n, x is the nth derivative of f. This is called the nth derivative. Okay, that is called the nth derivative of f. That is, if n equals 1, you are simply having the first derivative, f prime of x over, f prime of x, if n is 1. If n is 2, then this is technically f double prime of x. Okay, since putting lot of primes is hard, we say if n equals a big number, maybe m, you say f m, because it is hard to put m number of primes. Okay, otherwise you could write like 1, 2, 3, 4, several primes like that. If m equals 100, you have to put 100 such lines. So this is hard. Because of that reason, we simply write this m inside parentheses. All right, so go forward. We are in example number 1. Now you have to get the derivatives of f. Let me expand this notation. So you write this as, let me write it here. F of x equals 1. And then let me expand that term. First, it n equals 0, then that means f to the power f to the 0th derivative at 0, 0 factorial x to the power 0 plus f to the power 1, 0, and 1 factorial x to the power 1 plus f to the power 2 at 0 factorial 2 x to the power 2 plus several terms like that. And then you have the nth term, f to the power n, 0 factorial n x to the power n plus dot dot dot. Alright, so let me take this right word a little bit. All right. Okay, now you have to find these terms. You have to find that separately. You have to find that separately, this separately, and then this separately. Okay, you have to find those 4 terms. Go one by one. First, compute the first one. It is f of 0. That means the first 0th derivative. 0th derivative is actually the given function. Okay, the given function is the 0th derivative, which is right here, which is 1 over 1 minus x, and then plug x equals 0, and then you will get it as 1. All right, and then you have to find here, which is f the first derivative. First find the first derivative, and then you can plug x equals 0. You have to find the first derivative of this function, which is one minus x to the power minus 1. This is actually minus 1, 1 minus x to the power 2, and you have to use the chain rule. You will have minus 1. All right, and then you have to plug x equals 0. That means f first derivative at 0 should be minus 1 over 1 multiplied by minus 1, which is 1 again. All right, and then you have to find f the second derivative of f. Second derivative of f is actually the first derivative of the previous term, which is that. All right, so the second derivative of that should the second derivative of the function is same as taking the derivative of that function. Take the derivative of this function one time. So you write d over dx minus 1 minus x to the power minus, I'm sorry, this is plus, which is minus 2, and then take the derivative of that. That should be minus 2 times 1 minus x to the power 3 times minus 1. And now you have to substitute x equals 0. If x equals 0, this should be minus 2 multiplied by minus 1, which is 2. Alright, and then compute, you have already computed that, you have already computed this, you have already computed that. Now you have to compute this. Okay, computing this requires you to understand a pattern. Okay, pattern of these numbers. So this is that thing, and this is that thing, and this is that thing. But you have to understand a pattern in order to compute this. To understand the pattern, let's write few more terms. Let's write few more terms of this. Let's write few more terms. Now I'm going to write the third derivative. F to the power 3 of x is same as the derivative of the previous term, okay, so this is d over dx, and this is actually plus 2 times 1 minus, I made a mistake actually, and this should be plus 3. So this should be 1 minus x to the power minus 3. Okay, and you have to get the derivative of that. The derivative of this one should be minus 2 times 3 is 6, minus 6, 1 over x to the power minus 4, and then the chain rule will give you another minus sign. Okay, then you have to plug x equals 0. So this should be 6. Alright. Now check whether you can understand a pattern. Let me expand this a little bit. Here this is minus 6 multiplied by 1, which is 6. Okay, previously it was 1, again 1, 2, now it is 6. Okay, I don't know whether you can understand a pattern. If you can't understand a pattern, you have to go to the next term. Okay, that is f with the fourth derivative. Alright. So now I'm going to write down the pattern. 1 can be written down as factorial 0. Okay, you can just find out. You have learned this in Calc 1. 1 is factorial 0. And again, 1 is also factorial 1. Factorial 0 is 1. Factorial 1 is 1. Alright. And 2 is factorial 2. 6 is factorial 3. Now, do you see a pattern? This is factorial 0, and this is factorial 1, and this is factorial 2, this is factorial 3. Let me write this here. We see that f0, 0 is factorial 0, f1, 0 is factorial 1, f20 is factorial 2, f that is factorial 3, and this pattern goes like that. F, when you have nth derivative, it is actually factorial n. Okay, which is actually factorial n, which is right here. So you could plug this one. Let me mark this as equation number 1. Then by 1 you write one over 1 minus x, which is right here. 1 over 1 minus x equals, first you have to plug this thing, the 0th derivative, okay, which is just 1, and then come here. I have to plug the first derivative, which is just 1 times x, and then you have to plug this thing, the second derivative, which is just factorial 2 over factorial 2 times x square plus dot dot dot, and when you go to the nth term, which is right here, f nth derivative at 0 is right here, okay, which is factorial n, and it has factorial n already in the denominator. You could get that factorial n. Let me delete unnecessary arrows. Okay, here it is factorial n over factorial n x to the power n plus dot dot dot. So that is what you have from equation 1, and this is actually 1 plus x square. You can cancel these terms, plus dot 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 x to the power n plus dot dot dot. So this is the Taylor series expansion of 1 minus x, which is the given function. Okay, so this is the given function. This is the Taylor series expansion. Taylor series expansion at a equals 0. That means Maclaurin series. Taylor series expansion at x equals 0 means, which is same as Maclaurin series. Alright, so that is first example. Let's move to the next example. Example number 2. Find the Taylor series at a equals 0 of the function f of x equals e of x. All right. Same thing, you have to write down the derivatives until you see a pattern. Okay, let me write down the definition. F of x equals e to the power x equals f 0th derivative at 0 factorial 0 x to the power 0, f the first derivative at 0 factorial 1 x to the power 1 plus f second derivative at 0 factorial 0 x to the power 2 plus plus f nth derivative at 0 factorial n x to the power n plus Alright, so this is the Taylor series expansion, but you have to find these terms. You have to find that, you have to find this, you have to find that, you have to find this. These things supposed to be found. Let's go step by step. First, the 0th derivative. F 0th derivative of that is the given function, which is e to the power x. Now plug x equals 0, which is just 1, and then f the first derivative at x is actually ex. The derivative of ex is just ex. Then you just plug x equals 0, you get 1, and get the second derivative of ex, which is again ex. All the derivatives of ex is just ex. You know that. You learn it from Calc 1. And then you plug x equals 0. You will get 1 again. And then let's try f to the power f and the third derivative of f, which is again ex. Once you plug, you will get, once you plug x equals 0, you get 1. You see, everything is 1. 1, 1, 1, 1. Now you can guess about this. What is f to the power n? The nth derivative of this is just ex. Then you plug x equals 0, you get 1. Okay, it is always 1. Alright, it is always 1. Then take this as equation number 2. By 2, you write f of x, which is e to the power x, equals, this part is just 1. 1 divided by factorial 0 is 1, and this is just x to the power 0, and then this is again 1. 1 divided by factorial 1 x, and then this is actually 1 divided by factorial 2 x to the power 2, and then again 1. Here you have factorial n, x to the power n plus . If you simplify this, you will have 1 x plus x square over factorial 2 xn over factorial n . Alright, so this is the Taylor series expansion of ex. That is the given function This is the Taylor series expansion. at x equals, at a equals 0. All right. We have discussed two problems. Let's move to the third problem. Again, before moving forward, Taylor series expansion at x equals 0 means Maclaurin series. This equals Maclaurin series. Okay, keep that in mind. That's Maclaurin series. Go to example number 3. Find the Maclaurin series at, I'm sorry, when it says Maclaurin series, you don't need to say at. Find the Maclaurin series of the function f of x equals ln 1 plus x. All right. It says Maclaurin series, that is Taylor series at a equals 0. Both are having the same meaning. Right, let's go forward. First of all, I will write the corresponding series, which is f of x equals ln 1 plus x, which is f0 0 factorial x to the power 0 f1 x to the power 1 factorial 1. Give me a second. And plus f, the second derivative. I forgot to put 0 here. X to the power 2 divided by factorial 2 plus f nth derivative at 0 factorial n x to the power n plus . Alright, now you have to compute these terms. Alright, now just work one by one. First you have to find f, the zeroth derivative of x. The zeroth derivative means the given function itself. Okay, that is ln 1 plus x. Now apply x equals 0. Ln 1 is 0, and then first derivative of x, which is the derivative of ln x, d over dx ln 1 plus x. Derivative of ln x is actually 1 over 1 plus x, and then apply x equals 0, then it is just 1. and then you have to get the second derivative of x, which is same as getting the derivative of this function. That means d over dx 1 plus x to the power minus 1. This is minus 1 over 1 plus x to the power minus 2. This is derivative that you have learned in calc 1. So then you just plug x equals 0. Once x equals 0, you have minus 1 here. Okay, then just try the next term, which is give me a second, f, the third derivative of x, which is d over dx minus 1 plus x to the power minus 2. This is same as minus 1 plus x to the power I'm sorry, I made a mistake here. And this is the initial minus sign, and then I have to get the derivative of the rest. For that I'm using the power rule. If I use the power rule, it should be minus 2 times x plus let me write like this, minus 2, I put parenthesis, divided by 1 plus x to the power 3. Okay, to the power 3. Now you just plug x equals 0. Then you have minus 1 times minus 2 is plus 2. Alright. And then we can work further. And we have to do this until you see a pattern. First you got 0, then you got 1, then you got negative 1, then you got 2. Still the pattern is not clear. Okay, let's try the next one, which is f to the fourth derivative, and this, which is d over dx. This is 1 minus 1 times 2 is 2, 1 plus x to the power minus 3. Then the derivative of this one should be 2 multiplied by minus 3, 1 plus x to the power minus 4. Sorry, it's plus 4. Alright, and then apply x equals 0, and this should be 2 times minus 3, which is minus 6. Okay, I don't know whether you see a pattern. I see a pattern, but anyway, let's do the next term too. Okay, I'm doing only one extra term, so you can really understand the pattern. f5 x, which is d over dx, the derivative of minus 6, 1 plus x to the power 4, which is minus 6 multiplied by, this is minus 4 over 1 plus x to the power 5. Okay, and then plug x equals 0, and then this is 24. Okay, let's see whether you can see a pattern. This 0 can be written down as, give me a second, factorial 0. Okay, this 1 can be written down as factorial 1, and this negative 1 can be written down as negative factorial 1, and this 2 can be written down as factorial 2, and this 6 can be written down as negative factorial 3, and this 24 can be written down as factorial 4. Alright, it goes like factorial 4, negative factorial 3, factorial 2, negative factorial 1, and again factorial 1. Okay, this is the pattern you have. Now give me a second. I made a mistake. This is the 0 is not factorial 0. 0 can be represented as factorial. So I ignore the first term. Okay, let me ignore the first term. I ignore the above term because that can be put into the pattern. Okay, that can be put into the pattern. Okay, and then what I would do is 1 is also factorial 0. So let me put this as factorial 0. 1 is factorial 0. Again 1 is factorial 1. This should be taught in Calc 1. Factorial 0 is 1. Factorial 1 is also 1. Okay, alright, please note that. Factorial 0 is 1, factorial 1 is again 1. Okay, that's why I write like this. Alright, now I see the pattern. The pattern alternates like positive, like positive, negative, positive, negative, positive, negative, positive, negative, like that. And it is factorial 0, factorial 1, factorial 2, factorial 3, factorial 4, factorial 5, factorial 6. Okay, so that is the pattern. Alright, so let me put everything into the pattern. Okay, then I could write the nth term. Okay, you write several such terms. This means you write several such terms and finally you get the nth term. F n of x equals actually minus 1 to the power n plus 1 n minus 1 factorial. Okay, when this is 1, you had 0 there. When it is 2, you had 1 there. When it is 3, you had 2 there. When it is 4, you had 3 there. Always this is 1 less than the power or the derivative, number of derivatives. That's why when we have n here, this should be n minus 1 factorial. And this sign alternates. The sign in front alternates. So to alternate the sign, I put minus 1 to the power n plus 1. Okay, so this is the nth term. Okay, then let me mark this as equation number 3. By 3, I write ln 1 plus x equals this term was 0, 0 plus, and this one was just 1 over factorial 1x, and this one was right here -1 factorial 2x to the power 2 plus the nth term was -1 n plus 1 factorial n minus 1, and which is divided by this factorial n x to the power n plus . So this is the Taylor series expansion. Let me simplify a little bit. This is x plus, let me put minus here, minus half x square plus minus 1 to the power n plus 1. Then you have to simplify these two terms. Once you simplify those two terms, you will get just n in the denominator, and this is x to the power n plus . Okay, so this is the given function, which is ln 1 plus x this is given to you, and this is the Maclaurin series. Okay, that is the Maclaurin series. Alright, so that's it. That's the third example. The third example was a hard example. The first two examples were easy. Let me review the materials from the beginning. Today we are learning Taylor and Maclaurin series. This is an extension of the power series. Actually, Taylor series is an extension of the power series. Maclaurin series is an extension of the Taylor series. Alright, so the Maclaurin series is the Taylor series with a equals 0. We discussed the first example, which is an easier problem, and then we discussed the second example, which is also easy, but the third example was a little harder. Keep in your mind that in the exam I don't ask questions like example number 3, because example number 3 is a hard problem. I don't give such problems for your exam. I discuss this for you to understand there can be hard problems like this too. Alright, so thank you very much.